Okay, last time we started this topic, geometric design of highways, and this topic has three components: horizontal, vertical, and cross section. And horizontal means the plan view, which you normally do it from the development plan. Some of the other factors you need to consider for the horizontal alignment. Then we have the vertical alignment, which means you are looking at the road in the profile view, and again it contains gradients as well as curves. Vertical alignment is done after the horizontal alignment, but in some cases you may make some changes in horizontal alignment on the basis of this. Okay, so the main factor in vertical alignment is the design of the vertical curves. Okay, so these are 4 points you have to keep in mind for the design of the vertical curves. The first thing is you will see this point in all the things which we will discuss in the geometric design. The first point is about what? About side distance. Okay, so side distance, as I already explained in the last chapter as well, it is the most important element of the road design. Okay, the most important element of the road design is side distance. And the reason, what's the reason? Yes, why side distance is more important than anything else in road design? Yeah, exactly this reason. Your faces, which are showing me 12 o'clock right now. When you see something, then you can react, right? Right or wrong? Yes or no? Okay, so that's why side distance is the most important element. So on a curve, the side distance becomes more complicated because you are not going in a straight line. Okay, so that's why side distance is a consideration. The second consideration is drainage. Okay, so if you have a curve like this, okay, now what are you doing? You are deciding the direction of drainage, right? Your curve will decide where the drainage is going to be. Okay, so that's why. Then we have maintenance of comfortable operations, comfortable for the driver. Okay, the driving should look comfortable to him. Okay, there are some gradients, some curves which look very steep. So when you are on them, you go slower because you feel it's dangerous. Okay, anybody has gone to the mountainous areas? Okay, areas where they have mountains, you will see that any new driver will go much slower than the driver who has been driving there, because for a new driver just looking at those mountains is scary. Okay, so they become slower. Why they are getting slower? Not because they know the design speed of the road, not because of the road design, because they are not comfortable driving on this steep gradient and sharp curve and so on. Okay, so the appearance basically, okay, the appearance of the curve. If the curve looks very sharp, it has an effect on the driver. Okay, even if you put the design speed 120 km/h and you have designed it for 120 km/h, but it doesn't look safe. Okay, and the last one is maintenance of reasonable aesthetics. Aesthetic is related to the natural beauty of the area. Okay, this is why if you go to mountainous areas or areas near the beach or something, you will see the road design is slightly different. Okay, and this thing I mentioned in the last lecture as well. We try to follow the natural topography. Okay, we try to make as less disturbance to the environment as possible. Okay, so this is related to that. Aesthetic means the area should look natural. Okay, you should not destroy the beauty of the area. Okay, as much as possible. Obviously, you will destroy a little bit, obviously, or a lot. You are building a road, right? You're supposed to destroy the beauty and the people and everything. Okay, so but we make an effort, okay, that we try to keep it as less as possible. Cross section, okay. So from where can I see the cross section? Everybody has taken this AutoCAD course, right? So cross section means what? You cut the road. Okay, from where?
Side.
From the side, right? Okay. What's the difference between profile and cross section?
Profile, we look at its elevation going up and down, but the cross section, we cut it in the middle.
Both of them show elevations. Any other point? Profile and cross section, both of them show elevations. Yes, both of them show elevations. What's the difference between them? Newton, horizontal elevation.
Like this. And the cross section, you cut it horizontally. I mean, to show the pavement of the road.
The cross section is perpendicular to the road.
Yes, thank God. Cross section is perpendicular to the road. Yes, profile is parallel to the road. Along the length is profile, along the width is cross section. Okay, so cross section will show you what? It will show you lane, the width of the lane, the shoulders. You have made it for your term projects, right? You have shown me these things. So that was a cross section or the top view, anyways. So it will show the median, if you have a drainage channel, if you have any embankment. Okay, we will talk about embankment later on, but these are the elements which you see in the cross section. So the road cross section changes. Okay, and when you need to show the contractor the cross section of the road so that he can build according to it. Okay, like you do for the structural drawing. Okay, so you show the steel reinforcement in the column and the beam. So what are you showing? You have to show the cross section of that member. Okay, so without the cross section, nobody can construct it. Nobody knows how many steel bars will there be, what will be the width and what will be the depth and so on. So the same thing happens with the road cross section as well. You have to show the cross section of the road at different points so the contractor knows how to build it, how to construct it. Okay. So if the cross sections are similar, like there is no change in lane width, shoulder, and embankment, cross slope, everything is same. Okay, then the normal practice is to give a cross section after every 100 feet. Okay, so make a cross sectional drawing for the contractor after every 100 feet. Okay, so I have a cross section of 0 feet, then a cross section of 100 feet, then next one 200 feet, next one 300 feet, and so on and so forth. But this is when the cross sections are constant. Okay, they are same. But if there is a change in the alignment of the road or the design of the cross section, then wherever that change happens, you have to provide the cross section detail to the contractor. Okay, so you already have a cross section cut at 100 feet, but after 20 feet you have a curve now. So at the curve the road cross section will change. So you will not wait for you will not give the drawing for the next cross section which is after 100 feet. No, you have to give the cross section drawing where the cross section is changing. This is mandatory, right? Otherwise he will miss the change. Clear? Okay, so normal practice is cross section every 100 feet. Otherwise, wherever the change happens, you have to provide the cross section. In the geometric design, the most important element is surveying and stationing. Okay, we have already taken this course. So, station is what? A station is what?
100 feet.
100 feet is a station. 100 feet from where?
Origin of the road.
From the origin of the road or any point. From your reference point. Okay. So, from the reference point, every 100 feet is considered as one station. Okay. From the reference point. That reference point could be the start of the road. It could be some other known point as well. Okay. Any reference point. So, it is represented in this way, okay, with a plus sign. If you are talking about feet, then the number before the plus sign gives you total stations, like not the total station, total number of stations, okay, total number of stations, okay, and every station is how many feet? 100, okay. So if you crossed 100 feet, then it is one station. So before the plus sign, 1. If you crossed 1000 feet, then you crossed how many stations? 10. So number before the plus sign is 10, okay, and whatever is left is after the plus sign, okay. So you crossed a distance of 110 feet, so you crossed one station, 100 feet, and then 10 feet more, right? So 10 will come after the plus sign, okay. So something like this. So how many stations? 12. And how many after that? 52. Okay, total is? Okay, in meters, okay, it's not written here because it was not part of the book, but in meters it is 3 digits then, okay, or the one which they follow here, these are 3 digits. So you have 1, that means 1 kilometer, okay, and then you have, this means 100 meters, okay. So 1 is the number of kilometers you have, okay, and they call it chainage. Here they call it, the Ministry of Works or in Bahrain the term is chainage, okay. So this means 1 kilometer plus 100 meters, okay. This means 1 kilometer plus 110 meters, okay, and this means how many? 110 meters, okay. So the number after the plus sign is meters, the number before the plus sign is kilometer. Okay. Now let us talk about horizontal curves. So horizontal curves are part of the horizontal alignment, and the basic shape of horizontal curves is a circle. So almost all the horizontal curves, almost all the horizontal curves are part of a circle, or their shape is circular. The variation can be, you can have 2 circular curves joined together, okay, 2 or more circular curves which are joined together, okay. This is one of the variations, and in that case it is called as a compound curve, okay. So you can have a single circular curve, okay, and you can have a compound curve as well. So if you have a high speed road, okay, so on a high speed road the risk is higher, right, okay, because the driver is coming at very high speed, so we want to avoid the crash, because if the crash happens at that speed it will be very serious, okay. So then what we do, we insert an extra curve before the circular curve, okay. Before the circular curve we put an extra curve between the tangent and the circular curve, and that curve is known as a spiral transition curve, okay. A spiral transition curve is given on high speed facilities, okay, and it is between the tangent and the circular curve, okay. So the actual curve is the circular curve which we have designed, okay, but a spiral transition curve is inserted between them to provide extra safety, okay. So what is the difference between a spiral transition curve and a circular curve? The difference is the degree of the curve, okay. Every circle has a what? Radius, okay, and radius of a circle is constant, right? Radius of a circle is constant. A spiral transition curve is a higher degree curve which has changing radius. Its radius is not constant, okay. It goes from infinity and ends at the radius of the circular curve, okay. It has 2 points, right? The start point and the end point, okay. The end point is the circular curve. So circular curve must have radius what you have designed, right? So the end of the spiral transition curve is that radius, Okay, and the start is where? Where is the start? Where is the start of the spiral transition curve? Huh? No, where is it? Infinity is the radius, right? Where is the start? Where is the start point?
Before the horizontal curve. Before the curve we design.
Where?
Outside of curve.
Even we all are outside the curve, right?
Where the speed is not.
But we are not the start of the spiral curve, right? Huh? Even some of you are right now in infinity somewhere, but you are not the start of the spiral curve, right? Okay, a spiral curve is between two things, right? The curve and
No.
the tangent, yes. Yes, the start is the tangent, okay? Road has tangent and curve both, okay? The curve is also on the road, okay? Yes, so the start is the tangent. The tangent have radius of infinity. The end is the curve, and the curve has a radius, and the spiral curve will get to that radius, okay? So by gradually changing the radius, we facilitate the driver to go to the curve, okay? And why are we doing this? Because of high speed, okay? If the speed was lower, spiral transition curve is not required, because at lower speed the driver can manage to go from the tangent to the curve easily, okay? But at high speed road, as I said, the risk is higher, so we provide an extra curve for him which gradually changes to R, gradually changes to the radius. Got it? And we call it spiral transition curve. Okay. There are two things which are important for the circular curve. One is called the radius, the other one is called the degree of curvature. Okay, radius and degree of curvature, they are both related to each other. Okay, when you increase one, when you increase the radius, it has an effect on the degree of curvature as well. Okay, now what do we mean by degree of curvature? Anybody knows the definition of degree of curvature? Yes, anyone? No? Degree of the curvature is the angle of the curve which has a length of 100 feet or a chord of 100 feet. Angle of the curve when its length is 100 feet or its chord is 100 feet. Okay, now you know the difference between curve and chord, right? Okay. So now you see 100 feet in the top figure and 100 feet here as well, right? Which one has a chord of 100 feet, the top or the bottom? The top, okay, and this one has a curve of 100 feet, okay. So whatever angle is made here is called the degree of the curve, degree of the curvature. Clear? So D is degree of the curvature, okay, and the rule is what? That the length should be 100 feet. Now, the D in the first figure and the D in the second figure, are they equal?
Yes.
Their definition is same, but are they equal, like the number is equal? No, because the 100 feet curve cannot be equal to 100 feet straight. Chord is straight line, right? So a straight 100 feet cannot be equal to curve 100 feet. Okay, so the angle is not same. Okay, so both definitions will not give you the same answer. If you say curve of 100 feet, you will get one value of D. If you say chord of 100 feet, it will give you another value of D. Okay, we call both of them degree of the curvature. You cannot apply both of them in the same problem or in the same project because their values will be different. Okay, in road construction, we apply this one, which has a curve of 100 feet. In railway construction, they apply the top one, which has the chord of 100 feet. Okay, so they call it degree of the curvature, and the other ones also call it degree of the curvature, but the values are not same. Okay, so what is the relationship between degree of the curvature and radius, right? You know what is radius, right? Okay, now what is this 2 pi r?
Circumference.
Circumference, right? And what is this 360?
Degree of the whole circle.
Huh?
Degree of the whole circle.
Degree of the whole circle, right? So the circumference of the whole circle 2 pi r, and degree of the whole circle, the angle of the whole circle is 360. Okay, some of you are trying to remember it. Yes, it is. Okay, it is. Now believe it. And there was a time when they taught you this and you forgot. Now just believe it. Okay. So circumference, we said what? Which one we use for road construction? Which one?
Bottom one.
The bottom one. Okay. So bottom one has the curve of 100 feet. So 100 feet is what? It's circumference, right? 100 feet is the circumference. And what is the angle?
D.
D. Okay. So complete circle, circumference upon complete angle equals circumference of the part divided by angle of the part. Okay. So it's like similar triangle, right? Okay. So these ratios must be similar. Okay. Now here you see we have only two parameters. The rest of the things are constant, right? 100 is constant, 2, pi, 360, all of them are constant, right? Okay, so I can get rid of all these things and I can have an equation between D and R. Okay, so this is the equation between D and R. D is the degree of the curvature, R is the radius. Okay. And you can see D and R are what? What is the relationship between them? If I increase D, R will decrease. Okay, so they are inversely proportional to each other. Okay. Yeah. Which curve is better for the driver? The one which has more radius or the one which has less radius? More radius is better, right? More radius means D will be less. Okay. So higher radius is better. It means lower degree of the curve is better. Okay, for the driver. Got it? Clear? Okay, it will be safer and faster and so on and so forth. Okay, this figure, you cannot see it clearly, but you have already seen it number of times in highway and surveying course. So a horizontal curve has a starting point, we call it PC. Okay, PC is point of curvature. Okay, or point of commencement. Then the horizontal curve had the end point, we call it PT, point of tangent or point of termination. Okay, all these things are written there. This is start point, this is the end point. These are the tangents which you are trying to join with the curve. And the angle between these tangents is represented with delta. Okay, so this is the total angle I want between the tangents. Okay, clear? Is this degree of the curve? Delta. Delta is the angle, right? Is this the degree of the curve? No? Why not? Is delta degree of the curve? How many of you say yes? Raise your hands. And the rest are saying no, right? The rest are saying no, right? So why not? Yes. He is safe, he said yes. Smart girl. The others who didn't say yes, they must be saying no, right? Huh? So why not? What is the definition of degree of the curve? Tell me. What is the definition of degree of the curve? Angle for of a curve of what?
100 feet.
100 feet. Is your curve always 100 feet? No. Okay. So delta cannot or may not be the degree of the curve. Delta will be the degree of the curve if your curve is how much? 100. Clear? Okay. So don't mix that. Okay. You know about radius. You know about length of the curve. Okay. The point where the two tangents are meeting, we call it PI, point of intersection. Okay. So at point of intersection, we have the angle delta. Okay. And this is the angle we want for the curve as well. Clear? Okay. So So three main points: PC, PI, PT. The angle is delta, radius, length of the curve you already know, and what else? Yes, the distance from PC to PI is called tangent length, capital T. Okay, from the start point to the intersection point. Okay, we call it capital T or tangent length. Okay, the distance between PC and PT, the straight line. What do we call this straight line?
Go.
Chord. Okay, so this is the length of the chord. LC is the length of the chord. So L means the length of the curve and LC means the length of the chord. Okay. Then if you draw a line from PI, straight line, towards the center of the curve. A straight line from PI to what? Center of the curve. Okay. This line will intersect the curve. Okay. The point where this line intersects the curve, we call this distance as E, external offset. External distance. Okay. External distance from PI to the curve on this straight line. Okay. And this line will also intersect the chord. Okay. So this distance between the curve and chord on this line is called M, middle ordinate. Okay. So E is external distance and M is middle ordinate. Clear? Okay. Any questions? Okay, so this line is going from PI to the middle of the curve, center of the curve. Okay? Clear or not?
Yeah.
Okay. The total angle, as I already mentioned, it should be delta. Okay? The angle between the tangent and the chord, the angle between the tangent and the chord is delta by 2. Okay, the angle between the tangent and the chord is delta by 2. Okay, what else? Yeah, okay. To calculate these parameters, we use these equations. Okay, these equations provide you most of the parameters which are written there: length of tangent, length of the curve, length of the chord, middle ordinate, external ordinate, and so on and so forth. What are the two things which you need in almost all of them?
Radius.
Delta and R, right? Okay. Delta, you have to measure in the field. When you do the horizontal alignment, you know the direction of the road. Okay. You know where the direction is changing and how much the direction is changing. So that will give you delta. Okay. And radius, we design the radius. Okay. Radius is something we design. Clear? Okay. In the last topic, we saw the equation of radius, right? We used it as well. Okay. Let us do an example. We have two tangents which are meeting at this station. Radius of the curve is given. Angle of deflection is delta. Angle of deflection means delta. Okay. It's given. We have to find out the length of the curve, stations of PC and PT, and other relevant parameters which are these things. Okay. Now to calculate, as we already mentioned, we need R and delta, right? We need R and delta. We have R and we have delta as well. Okay. R is 1200 and delta is 14. So we can calculate all these parameters, right? So let us do this first. R is 1200, delta is 14. Okay, give me these things, T and L and M and E and LC. Huh? 147.34. L is
What is D?
what is D? See, it took you 2 minutes to ask me this, right? Now from where will I get D? D has a relationship with what? Radius. Radius. Okay. So first we need to calculate D. Okay. So D is 5729.6. How much?
4.77.
4.77. This is an angle, so obviously in degrees. Okay. This is in degrees. Okay. Now moving on. Length.
293.5.
M. Hmm?
8.9.
E. 9.0. Okay. And LC. 292 point. Okay, so all the relevant parameters are found. Now we need to calculate the stations. Okay, the station is the distance from a reference point. Okay, so which station is given to us? The station for what is this point? PI. Okay, point of intersection. Yes. Okay, so this is given. Okay, so I know that this point is this much from the reference. Okay, and PC is how far from from this point?
T.
Tangent. Okay, so from this one I will subtract the tangent length. It will give me PC. Okay, how much is that? Point something? 68. Point? Yeah? Hmm? 67.68. Okay, so now I know how far is this point from the reference. Okay, and how far is this point from this point? How far is it?
PC plus C.
Okay, from PC to PT is what? The curve, right? From PC to PT is the curve. Okay, so the length of the curve. So you will add the length of the curve to get PT. Yes. How much? You can what? Not plus, minus. I will come to it. Point what? Huh?
33 plus 61, 1.6.
Yes. Your question. Yes. We can do this as well. We can do this as well. Okay. This tangent length, both are same. This tangent length equals to this tangent length. Okay. We can do this as well. There will be a slight difference in the answer. You will not get the same answer because L is not 2 times tangent length. Okay. What is the tangent length? This much, right? Okay. If you do this into 2, you will not get L. Okay. So there is a difference. There is a difference in both the points. Okay. Here in this picture, it looks the same. In this figure, it looks okay. I do this plus this, no problem. I do this plus length, no problem. Okay. But there is a slight difference. Okay. So which one is more accurate is this one. Okay, because in the end I want to construct what?
Curve.
The curve, not the tangent. Okay, so my point should match the curve. Okay, so when you will do this plus tangent, you will get slightly ahead. It will be slightly more. So your curve will become longer. Get my point?
Yes.
When you will do this plus tangent length, you will not get PC at this station. You will slightly get it slightly ahead. Yeah, okay. So your curve will become longer by 1 or something feet. Clear? So this one is considered more accurate. Any questions? Okay, we have already discussed superelevation earlier as well. Superelevation is done because of the centripetal force. So superelevation tries to push the vehicle towards the curve. Okay, and this is the equation we have used. Superelevation is given in terms of percentage or in fraction. And yes, so it is measured across the cross section of the root. Okay, so it will be this height divided by the width of the root. Okay, 4 to 12%. We already mentioned this. Yeah, value of superelevation depends upon these things: the climate. Okay, something which I mentioned the last topic as well. If your climate is such that you will frequently have wet surface, then the superelevation should be less, because in wet surface there is a chance of sliding. Okay, terrain. Okay, again something which I mentioned in the last lecture. We try to follow the terrain. Okay, if the terrain is steep, then superelevation will be higher. Okay, if the terrain is level, superelevation will be close to level, meaning lower. We will not make it 0 obviously, but it will be low. Development density. Development density means population around the road. Okay, more population around the road, the speed of the road would be what? Less. Okay, more development density means less speed, and less speed will also mean less superelevation. Okay, frequency of slow moving vehicles, such as, what is a slow moving vehicle?
Trucks.
Trucks, right? And some people who are in the car as well, right? Some of them. So trucks, okay. So if they are in higher number, so what should you do for them? Increase superelevation or decrease it? Decrease it. Okay, decrease superelevation, because more superelevation there is a chance, because they are heavy, so there is a chance they will flip. Okay, so less. Okay, some practical consideration. The first thing is, I already mentioned it for the vertical curves, the comfort of the driver. Okay, if you give too high superelevation, none of these problem is there. Area is open, there are no slow moving vehicles, terrain is fine, and so on. So you give higher superelevation, but this higher superelevation looks uncomfortable for the driver. Okay, so you may have seen it happens. Okay, and you may be doing it as well. When you are on a curve and you see the superelevation is very high, you try to avoid the side, because you feel if you go to the side of the road, you are going to the highest point of the curve. Okay, so you try to go in the other lane, you try to avoid it. Okay, and obviously if you cannot do it, then you go slower. Okay, so comfort of the driver should be there. Snow, ice, anything which makes the pavement wet should be taken into consideration. Okay, the other points we have already discussed. Apart from this one, okay, at intersection they are saying you can eliminate the superelevation, make it 0, or whatever is required for the drainage, like you design without the superelevation. Okay, then this is called low speed curve or low speed turning, because in intersection what happens? You are going into the intersection, right? Okay, so either there will be a stop sign there, or there will be a roundabout, or there will be a signal, whatever it is. You will not come at 100 kilometers per hour and make the turn. Okay, you will reduce your speed. In many cases you will stop and then make the turn, right? So it's a low speed turn, that's why we can eliminate the superelevation. Coefficient of side friction is coming from here, okay? So the factor, this is already discussed in the previous chapter as well. Okay, consider a road which has a design speed of 60, maximum superelevation 6%, okay? What is the minimum radius and degree of the curvature for this facility? Okay, for radius, we'll use this equation, right? Okay, give me the radius. Yes. Okay, the speed is 60, right?
Yes.
So for 60, the F value is 0.1.
One three three 1,300 capital.
Point.
0.3.
Okay, and the degree of the curvature, as we have done earlier,
4.3.
29. Okay, clear? Okay, very easy. We have done it previous topic as well. For this highway, if we make the curvature 1500 feet, 1500 feet, then what super elevation we can have? You will use the same, but now put the radius as 1500. What will be your super elevation? Zero 0.04 means 4%, right? Super elevation is in percentage. Okay, 4%. Now what happened? What super elevation we took for 1300? How much super elevation was it? 6%, right? 0.06. Okay. When you increase the radius, super elevation decreased. Okay. Because when you increase the radius, the curve becomes bigger. So it becomes easier for the driver to go even at the same speed. Okay. So when you make the curve bigger, you don't need higher super elevation. Okay. Because centripetal force is less now. Okay. Okay, super elevation is achieved in two steps. The first one is called as tangent runoff. The second step is super elevation runoff. Okay, whatever changes you make on the road, they have to be done gradually. Okay, you cannot change the cross section of the road to anything suddenly. So it was 2%. It was, you can see it here. This is the normal slope of the road, like this. We call it the crown. Okay, for some reason. And then you are doing it for super elevation, right? Super elevation is like this. Okay, so to change it from here to this, you cannot do it suddenly. You cannot do, okay, 0.0 was this and 0.1 is this. Okay, no driver can go through this. So you have to do it gradually. Okay, so what do? First of all, we make the outside slope as 0. The slope of the outside edge as 0. So it was like this. Then you raise it to, or do something to make it 0. Then from 0 it goes to super elevation. Got it? Okay. So these are the two steps. First step is to go from normal crown to 0. The outside edge goes to 0. From normal to 0. Okay. This is called as tangent runoff. Okay. And the second step is to go from this 0 to full super elevation. Okay, and this is called as super elevation runoff. Clear? Okay. Now, this process is called as rotation for super elevation. To go from normal crown to super elevation, this process is called as rotation for super elevation. And rotation can happen in these different ways. So, they are, no. Inside, outside, and okay. 3 different ways. Rotation can happen in 3 different ways. Okay, same 2 steps. Normal to 0, 0 to full. 2 steps. But it can happen in 3 different ways. Rotation around inside edge, rotation around outside edge, rotation around center line. Inside, outside, and center line. The most common one is center line. Rotation around center line, which you can see over here as well. This is rotation around center line. Okay, so what does it mean? Rotation around center line means the other edges of the road will go up or down. Center line will remain at the same elevation. Elevation of center line is same in all the stages. Okay, this is rotation around center line. So if I have to increase the slope or decrease the slope, I will either move the outside edge or the inside edge. Center line will not be moved. Clear? Clear? Okay. Then rotation around outside edge means what? I will not change the elevation of the outside edge. Center line and inside edge will change. Okay. And the last one is rotation around inside edge. Okay. So elevation of inside edge will not change. Center line and outside edge can change. In all these cases, in all the cases, superelevation is going downwards, right? It's like this. Which edge is down? Which edge is this and which edge is this? Down is what? Inside or outside? Inside. Okay. In all cases. In the end, the inside edge should be down, the outside edge should be up. Okay. How you make them? You can rotate around center line, you can rotate around outside edge, you can rotate around inside edge. Okay. But eventually this is the case. Okay. These diagrams you see here, they are without median. See? All these diagrams, you don't see a median, right? When you don't see a median, the whole road is like one cross section. Without median, the whole road is one cross section. So 1 lane, 2 lanes, 3 lanes, the whole road is what? 1. So you can see the rotation is happening in all the lanes. Okay? But if you have a median, then one direction is one road, the other direction is another road. So superelevation here will be done separately, superelevation here will be done separately. Median will not change. Median will not change. So for one direction, median is the outside edge, right? For one direction, median is the outside edge. For the other direction, it is the inside edge. Okay. So with the median, I will do the rotation around the median. If it is the inside edge, rotation around inside edge. If it is the outside edge, rotation around outside edge. Clear? Okay. Any questions? Okay. Thank you.